Hi, I'm Cunitz from Hortonworks, and really, it's always great having this session before lunch, but there are two questions we wanted to really spend time and go through today. One is, what is Hadoop, and why do you care about it in a room like this when you're talking about telematics? We'll go through that. And second, since everyone keeps saying, who's the elephant in the room? Based on our logo back there, I guess that's us. So let's talk about Hadoop. So first is, why do you care? At this type of conference, why would you care? Everyone's been talking, from what I've heard, about three core things. What are the devices and the sensors and the embedded capabilities in an automobile or something else, and how do you extract that information? Second, how do you transfer and move it to a place that you can analyze and do something with it? And third is, you need a place to put it. Where are you going to put all that information, store it, and analyze it at scale as you look at years or decades of information? It could be diagnostic information, data, customer driving patterns, et cetera. And you want to look over a very broad time, but you also want to have many different types of data that you want to correlate and look at. That is what Hadoop was designed to do. It was designed about, call it a decade ago, as an open source project, very specifically at the time focused at saying, how do I index the internet? And 10 years ago, why would somebody like Yahoo or Google want to index the internet? What they're looking to say is, what are the patterns of what are people doing on the internet? What are they clicking on? How do I understand what they've clicked on? And how do I predict what they're most likely to click on next? An advertisement, a banner ad, something like that. So think about that. I want to take all this historical information, understand what a consumer is most likely to do, and target it to a particular person. And I want to be able to predict what they'll do next and present them with something. That's what Hadoop was designed to do, except the challenge at that time was you couldn't index the internet and fit it on one server. That was 10 years ago. Think about that now. So I had to come up with a way of saying, how do I distribute all this across many, many, many different commodity servers and do this very economically so I can process this data and provide results in real time back to whoever needs it. That's where all this started. And when you go through that, you go through those things I was talking about. How do I go extract the information? How do I transfer it? And where do I store it and process it? Hadoop is becoming that platform in many of the firms to go do that. So this is from Forrester. So in the IT world, a very distinguished analyst who looks at this and says, over the next 5 years, their belief is adoption is the only option, meaning they have predicted that every company will utilize Hadoop in some way over the next 5 years. So it's not a question of, is it going to work? It's how should we go use it in the enterprise? And why is that? Now, think in this conference, two core types of data. All the traditional data everyone has stored for years, which is a consumer, what they bought, credit card information, they bought a transaction, they bought this in the store, whatever, all of that information. And now you have all these new types, all the ones listed on the left, the clickstream I was talking about from a Yahoo or Google. Sensor, data that's in a car. Where am I going to go put that? What do I go do with it? Security logs. All this data needs to end up somewhere. The growth of it is enormous. If we just go through, last two speakers, 26 billion devices connected to the internet in the next 5 years by 2020, 1.5 billion of those are expected to be cars. All of that device data needs to land somewhere, and it doesn't fit in a current database. That's why it tends to go into Hadoop as the platform to store and process it. And that growth in data is not going to go away. So what have most traditional companies done is they've looked at this. They said, I have systems today. I have a system for managing my front office, my CRM system. I have a system for managing my back office, my ERP system, or my supply chain management systems. I probably have systems for managing my engineering and design, my CAD systems, et cetera. So I have all of these. What they tend to do is first say, well, let me stick all this new data in one of those systems. And what they find out is they end up with something that just wasn't supposed to be. They think they're going to get something that's going to go help them, but it's not exactly what they thought they're going to get as a race car. They thought they're trying to go create something that's going to give them the ability to go process that data. This is what they thought they were getting. This is what they ended up with. And so they realized they need a better solution for how do I go store this information. And in the world, that's where Hadoop fits. It fits in, take all these device data and all the information that's coming off the connected cars, or change car to humans with Fitbits, change car to an oil and gas, it's the sensor on a wellhead. You can go down industry by industry, and it's the same. There's all this information that needs to get transferred. It needs to go into a central platform where I can store and analyze it. And I want to correlate all this information that's coming from, say, diagnostics and engines and others with patterns around the people and their driving patterns and what they're doing and potentially the consumer and who they are and how much they spend. And I want to get a picture that I can predict what's going to happen next and take action based on it. And that's where Hadoop fits in the middle there to give you those insights. And now as you look to say there's all this other type of data you're also going to want to go track, or somebody's going to want to go track as you move towards autonomous car or other things, how do I also pull all of that information into a common place where I can analyze it, make sense of it, and take some action based on it? So what has come out of that is a platform called Hadoop that says, I can now use this and take any type of information, store it economically in a common place. Tends to be called a data lake, a common set of servers that can store all this information in the same place. I can deploy it in many different ways. I can run it on premise. I may want to take advantage of the cloud. I may want information shared. But it's really, how do I get any data that I can manage any way I want to and put it any place where I go need it, in my premise or a partner or the cloud? How do I have a way to go do that? So let's talk about what are some examples of how companies do this today. This is helicopter company. Think of helicopter as a car that originally started with saying, the way I'm going to go take this information, I'm going to stick a USB stick into the helicopter. At the end of the flight, I'm going to pull that off. I'm going to have this diagnostic information I could look. And that was great, and it worked. Very manual process, expensive, stored small amounts of data. Then they realized, well, what if I can have a sensor in the helicopter or many different sensors, stream that data back to a platform, be able to take that and correlate it and say, I have all this data coming in, but I can go tie this to the pattern and the route that the pilot was flying, the weather that was happening on that particular day, the engine diagnostics of what's actually happening. Compare that across many different helicopters, across years of data, and say, on average, this type of part is going to fail if we see these characteristics. Now as that data is streaming in on that specific helicopter, I can see that's probably going to have a part failure or a high likelihood. When that helicopter lands, let's make sure we maintain it and fix that. On that particular helicopter that was putting out that piece of data that shows its part's about to fail, versus saying just generically after this period of time that part may fail. That's now taking broad analytics across a large set of data, in this case in their world around helicopter flight patterns and diagnostics, and comparing it to that specific piece of data around what's happening with that helicopter right now to see if there's an action they need to go take. That's an example of how Hadoop would be used in their world to do predictive analytics and predict part failure on a particular helicopter, and now tied into their workforce management systems to make sure when that helicopter lands, they schedule someone to be there with the right part. Now that ties into the supply chain management system to fix that helicopter as it lands. That becomes a highly integrated ecosystem of you're tying many, many different types of data together to take an action, which is fix the part in that helicopter. Take that in the same world into automotive. Because in the automotive world, it's no different. You need the same way of storing that information, breaking down the barriers, and changing the business models, right, of what the companies are doing out there. So what are some of the ways that Hadoop is used in automotive today? We just talked about preventative maintenance. Very common way as well to say, I want to take all that information across all the cars and understand, is there a particular vehicle that's about to have an issue? This is great because think of it from a warranty recall perspective. As opposed to getting a flyer in the mail saying it's a warranty recall for your particular vehicle, what if there's a way of saying, it's not on average this part's going to fail. We know that particular vehicle is about to have an issue. Let's notify that consumer. That helps you build a better consumer experience to help that consumer understand you're only going to them when their particular vehicle is going to have an issue, not generically that you're going to have an issue across the whole industry. So the whole idea of doing this preventative maintenance and what you do, Hadoop becomes the platform to go store and process all those different types of information to correlate it to get a picture on what's happening on that particular unit. Other ways it's being used today across other companies is to say, from an engineering perspective, how do I understand and take the data from driver habits, what people are doing in the car, how often they're using particular things on the infotainment system, how often they're using particular features of the car, how different sensors are reacting. How do I take that information, build a pattern on what we think the consumer is going to want in the next car, and use that to improve how we build the cars the next time? Think of that on the infotainment side. Think of that on what you can do around the car itself. And that's why, for example, we announced a partnership today with Harman, right, very specifically looking at how do you merge those two worlds of data to get a better view of how you build a better car in the future by taking the information around usage patterns from the consumer, what they're doing, through the head system and through the infotainment of what they're doing in the car. That helps the engineers with valuable data on what to improve and what to work on next. So we, as I just mentioned, recently announced that today. Perfect example of taking different types of information, diagnostics information, for example, coming through Harman, driving patterns, et cetera, how I put that together. And then what are other industries that care about that data? Actually, before I go there, you think of usage-based insurance, right? Insurance companies want to know what are the driving patterns of what's happening with that particular car. Can I potentially offer a different insurance rate to that particular consumer based on their specific driving patterns that they're able to go track? So many different ways that companies are looking at monetizing this data, because now they have it, they can find new insights, they're finding new ways to go monetize that data and determine what they can go do with it. So if you're going to say, what does the sum of this data look like? This would just be an example of a visualization of some of the data. You can go see this in the booth with LHP, and they happen to be showing it there, in particular in this case, with City of St. Louis and looking at failures of turbos on the engines and being able to take the diagnostic data. In this particular one, what this is showing, on a particular date, the intake manifold pressure was very high, probably starting to have an issue. Let me correlate that to the weather for that day to see if that was it, maybe to the driving patterns of that particular driver. Is it an issue with that driver or that engine? And start to correlate and find insights into what's happening and why the manifold pressure went up that particular day. And again, this is something you could see with LHP in one of the booths. They show in great detail how do you take all these pieces of data around transmission information, engine information, turbo information, find insights, and improve that particular vehicle and the building of all future vehicles just based on a lot of this information. And that just gives you a simple screenshot of one type of diagnostic data that can be tracked. So other use cases, vehicle location for fleet services, real-time exceptions, the usage-based insurance. All of these that are here are not futuristic or things we're saying these are things that could be done. These are all things being done by different manufacturers, OEMs, and others today, leveraging Hadoop as a platform in terms of what they can do. Not everybody's doing it, but these are all actual use cases of how it's being used today. We talked more on the car side. There's also the infotainment side. Spotify is a very large user of Hadoop, and they use it two core ways. One is they have to figure out from a billing perspective who's listening to what songs and how much do they pay each artist. So they have to analyze vast amounts of usage pattern and data and predict how do they tie that to I need to pay this artist that amount. Second thing they need to figure out is Spotify is effectively a web application to many of you, and they want to know how do I improve that web application, that user interface. So they do a lot of testing where they'll put out many, many new features separated across different audiences, do A/B testing across that, very quickly, within hours, determine what the usage pattern and which feature is going to play much better, kill off the feature that's not working, and move their platform to that new feature. So in real time, they're making changes to their system and the features they're putting out there based on data of millions of users and what they're doing in real time to determine what's the more likely platform that's going to be adopted and how do they drive more usage of their platform. But that's analyzing many, many millions or billions of events at the same time to make a decision in real time. That's an example how Spotify uses it, very large user out of Europe in terms of what they're doing. So all of that comes down to you ultimately need some version of a reference architecture. This is a reference architecture for connected car, saying, and you've seen many different versions of this today. This is saying on the server side, the component where you're storing all the data, I need a place to store all that information. I need a way to secure it to make sure when it's in there, it's secure. I need to know how it's governed, who has access to the data, what can they do with it, who can go analyze it, what type of analytics they're allowed to go do around it. And then I need an interface layer, a way to ingest all that information from either a device, from a person, from a system, from a computer. How do I have a different way of ingesting all that information, which, by the way, all comes in different formats, and then put it into this common bucket called Hadoop, and then correlate across all these different formats to get an insight. That's effectively what Hadoop does, and this is a visual of an architecture for that. If you took that down a step further and said, what would it actually look like in practice? Right? On the left, streaming information in. You've got users on top, and you've got a platform, and in this case showing, in some cases, on the right where it says MapReduce, that's a project in Hadoop that says I want to do large-scale batch analytics over billions of events. You in the middle, somebody saying, I want to type in a query, I want to ask a question, I want to get a response back, just like you would today into a computer system. And then on the left, Storm, I want to stream data in, I want to have it come in high volume like sensor data, and as that individual event comes in, I want to correlate it against this analytics I have over here and determine if I need to go take an action in real time. All of that is tied together in a common platform called Hadoop. So that sounds like that's great. Hadoop is one thing. Well, as I started up front, Hadoop is an open source platform, right? We happen to be the company behind it, spearheading it, and driving much of the innovation of what's happening there. But in the end, this is what Hadoop looks like. There are 20-plus different projects, all run by independent teams. Some of you in this room may be committers on some of those projects, all building to a real-time streaming engine, or a batch analytics engine, or a security framework. These are all independent projects, all tied under Apache Software Foundation, which means it's governed by an open source software foundation, right, and all the governance that comes around that. But ultimately, as a consumer or a user or an OEM or a customer, you don't want to go take all these things and figure out how to go tie them together and which versions work together and which versions don't. You want to say, give it to me as one common platform that all works out of the box, that's tested, and that has a company behind it to go support it. So if it breaks, we can get it fixed. And if we need new things added to it, we have a place to go to get things added to it. And that's what we do. That's who Hortonworks is. We are that company behind Apache Hadoop to drive the innovation with our engineers, but then also to help companies get it working, installed in their environments, integrated to their other systems, and support it when it breaks, and help them get additional features in when they need that. And the data platform, HDP, the Hortonworks data platform, is designed to say, how can you have all of those different projects in one place as a single entity for how you're going to go run your business and be able to go get the insights into the analytics that we talked about earlier. And I can do that in batch, I can do that by asking questions and querying it, or I can stream in data in real time, and I can do all of that across the same platform. And this platform, Hadoop, over in 10 years, has gone from basically doing one or two things to many different things, where if you ask most of the IT analysts, they'll say this is the next generation data platform for storing and managing all of the data in an enterprise and creating a common data lake as a single repository of all your data, and then allowing people to go access that in the view that they want, as a consumer view, as an engineering view, as an OEM view, as a system view. Allow them to get different views, but all the data is still correlated and sitting in one place. As Hortonworks, as I mentioned, we are the company behind that. So we are doing the work in the open source community. We feel very strongly that this is a platform that should be made available in open source for two reasons. One, it allows us to aggregate the best minds out there who want to work on it and work with us. We'll continue to drive the leadership of what gets put in next, but allows us to make sure that there's a lot of people participating and providing input and feedback. And that's why you see many of the partnerships we have with companies like Harman and LHP and others in this world to say, we want to make sure that we're bringing in the right feedback so this platform services the needs of this industry in the right way and continues to have the way to go deliver the analytics that many of the OEMs and others are looking for. So with that, I want to thank you all. I know I'm the last thing between you and lunch. And just say, as we look at Hadoop, one, transformational in terms of the business models it's enabling for companies. You heard many different things around companies saying they want to monetize this data in new ways in the connected car. Hadoop becomes that storage and processing platform to allow you to get those insights. It's already pervasive, used in many of the OEMs today for various projects as they're looking, and all looking to expand as they move to say, how do we turn the car into a mobile entertainment device from where it is today? And Hadoop is enterprise class, meaning many large companies are using it today, and that's our charters to continue to add the capabilities to make sure it's secure, it's governed, it can be operated in your environment, integrated into your existing systems, and used by standard users in the way they want to do it. So with that, I want to thank everyone for this, and I assume it's time for lunch, right?
Yes, it is. Thank you very much. Cheers. Thank you.